love the chase and the hunt, and I set the pace when I'm running. I always
Namaste friends. So today is chapter 64 in the entire Python and lesson 23 in the NumPy. So what did we see so far? In the distributions we saw normal distribution, binomial distribution, Poisson distribution, and as of yesterday we even saw uniform distribution. So the uniform distribution is an equal chances of occurring. The Poisson is like, okay, I've eaten 2 times, what is the probability of eating for the 3rd time? The normal is like, everything falling under the bell curve, the Gaussian. We saw the binomial, which is also discrete. And we also saw that binomial to discrete can still be converted to normal with almost continuous data. So we saw all those things, we saw everything. And we said with the random dot normal it is normal, random dot binomial binomial, random dot uniform uniform, random dot Poisson Poisson, and stuff of that nature. So today in the same family we are going to be seeing logistic distribution. So what is a logistic distribution? The logistic is used to actually describe the growth. Sometimes we say what is the logistics involved, how we are going to transfer, how we are going to transport, the logistics involved in moving things from A to B. Okay, so the logistic is always used to describe the growth. It is extensively used in machine learning, in logistic regression, neural networks, etc. So now you know why it is important, just like the Poisson. Right. So in this logistic, it also has 3 parameters. Only Poisson so far has 2 parameters. So here it is LOC, which is very similar to that of normal, which is a mean, and the default value is 0. The scale, the standard deviation, the flatness, which is 1. The size is the shape of the returned array. The size is more or less like a common denomination, everything. Alright. So in this logistic, what we are actually doing is we are actually taking this and I'm actually running the entire thing. So as I said, the first statement is a default statement. From NumPy import random. And then we say random dot logistic, because random dot normal, random dot binomial, random dot Poisson, we know this. We have already talked to. So this is random dot logistic. So here what we say is the scale and what is the size of the returned array, and this is the mean. Okay, so this is what we talked, and this is the mean, okay, which is the peak, and the default is 0. So this is what we talked. Alright, so when I actually print this, okay, this is 2 comma 3, so 2, and this is 3. Alright, when I'm actually printing this, very nice. So when I want to visualize this on my logistic, as I said, the first 3 things is the same. Import my random, matplotlib, seaborn. And then the seaborn distribution, I would say random dot logistics, and then I say my histograms is false, and then I say plot dot show. So let's see how the logistics comes in. So the logistic, if you see it's more or less like a Gaussian curve, like a bell curve, inverted bell curve, so it is actually coming like this. Alright, and the histogram is false because I don't have an histogram here. Alright, so now that actually begs a description. What is my difference between a logistic and normal distribution, because both of them look more or less the same? Well, you're right. When both the distributions are near identical, the logistic distribution has more area under the tails, which means it represents more possibility of occurrence of an event further away from the mean. Or how do I actually say this? See here. See here. So this is something very good, right? In life, when everybody say okay, you're done and over, and there is no chance, when you actually rise up like a phoenix, how good it is. So the possibility of occurrence of an event further away from the mean. Okay, there is no mean, there is no chance, there is no average here, but someone actually rising from the ashes. For higher value of scale, the normal and logistic distributions are near identical, apart from the peak. Okay. Now, if you want to actually see the difference between a logistic and your normal distribution, let's actually see. The first 3 things are the same. This is a normal with the scale, size, histogram is false, and this is normal. I have a logistic and I have a name logistic. I'm actually plot showing. So if I actually run this, the blue is the normal, and see this color. See, I have a even when it says this is totally dyed here, there is no more chances. The logistic actually gives me a chance. It says like, anything can actually occur. So this is like, imagine a life where everybody has said like, oh my god, this guy is useless, he's not going to come, it's a waste of time, there is no average, there is no way of returning, and then you rise like a phoenix, and then like you prove everybody wrong. What kind of satisfaction is that? Two things, right? Proving someone wrong in a positive manner, and rising as a phoenix, and proving that you're capable of things. It is just like a matter of bad time that you actually went through. So this is that logistic, and for the population growth, and this is the normal. I'm just giving you layman's example for better understanding. Okay, just apply it accordingly here. All right. Having said that, you saw the difference between logistic and you saw the difference between normal. You saw the difference as well, and this actually concludes our logistic distribution chapter. I trust you have actually enjoyed it and understood the same. If you have any questions, kindly contact me. I'll actually try to explain it to the best of my abilities. Like always, I would like to thank two persons. One is you for giving me a golden time, and the other is my wife Jayashree for allowing me to follow my passion. Till we see next time, take care, cheers, and thank you.